name is Michael Carducci, and this is a talk that I'm very excited to dive into with you. I think this is going to be a lot of fun. And so let's kind of start with the customary introductions. I'm a hands-on software architect. I'm a knowledge graph grease monkey. And as our wonderful MC mentioned, I am also a magician, a mentalist. So I guess what that means is that I live somewhere at the intersection of magic and technology. That's where I am. And the magic that I'm most interested these days involves helping organizations navigate bleeding-edge technologies and do things with technologies that at one point we never thought were possible. In other words, I know a thing or two about sufficiently advanced technology. I know a thing or two about software. And as a magician, as a mentalist who has traveled the world and performed all over the world over the last 25 years, I also know a thing or two about sorcery. And I want to start with the story of a card trick that fooled a room full of magicians. And in fact, I have a deck of cards. I have these right here. And since you're in the front row, I'm going to toss these over to you. Go ahead and open them up. Just start mixing them up. Make sure they're all mixed. And we'll get back to that in a moment. But the story of this card trick continues to this day. Because somewhere in the world, there's a group of magicians, a number of magicians, who are still baffled by something that I showed them almost 2 decades ago. Or maybe they figured it out. I don't know. But whether or not they have solved the mystery, whether or not they have figured out the magic trick, revolves around knowing one single fact, one linchpin. And so, like I said, this was about 2 decades ago. It was 2004. I crossed an ocean to attend my first ever live magic conference. So I want you to imagine it's something like this, but instead of front end and back end and architecture and soft skills and tech leadership and languages and frameworks, this is all magic. All of our speakers were magicians. All of the attendees were magicians. It's a wild and an interesting place. And I remember when I thought this trip was a long way. And then I came to India. But it was my first ever live magic conference. And I remember I was on a website of a magic shop, and I saw the advertisement. By the way, I think we can safely point out that our friends here at Salt March definitely have much better designers. But, you know, it was 20 years ago. You could get away with web design like this. But I saw this here. And the big banner there, Daytona Beach Festival of Magic 2004, starring Jeff McBride. That got my attention. Jeff McBride was a performer, a magician, a creator, a thinker that I'd always looked up to. And I clicked on that link to dive into, to learn a little more. And I just was blown away by the headline acts. Because not only did we have Jeff McBride as one of the headline acts, we also had Darwin Ortiz as one of the headline acts. A very interesting magical thinker, very talented magician with a deck of cards. And of course, the sage, the luminary, Eugene Berger. 3 towering magicians, towering minds, towering creative forces that I had looked up to, that I had admired, that had been big influences on my learnings as a magician. And at this conference, they would all be there, and I could meet them and work with them live. I couldn't pass this up. Now, of course, going to another country to go to this convention, I didn't know anybody. And I'd never gone to anything like this alone. I lived in the UK, and I'd gone to conferences and conventions in the UK with my friends, with the broader community that I knew fairly well. But here, I was a stranger. I knew nobody. But that would change the night before the conference started. So I arrived, and I sat in the restaurant, and I dined alone. And so in those occasions, when I'm at a restaurant in a distant town and I'm eating alone and just sitting alone, I people watch. From my table, I just observe what's going on around me. And there are a variety of interesting folks to watch. There were the retirees who had since retired from their jobs, and they took the opportunity with their newfound time to rekindle a childhood hobby. There were the overbearing stage parents, the stage mothers, who would just stand over their children and just relentlessly try to mold them into future Las Vegas headliners. And then there were the adolescents, these people who spend every waking moment of their lives trying to learn and practice and just drill over and over again the most difficult, the most technical, the most challenging sleights and moves that are known in the field of magic. And that last group, they are a lot of fun to watch. And so I'm sitting there, I'm watching a whole group of these magicians. And they're just showing all of these crazy moves and maneuvers and tricks and flourishes. And it was sort of like, I want to say the legerdemain equivalent to a rap battle. That they're all there, each one trying to one-up the last one. Oh, that was cool, let me show you this. Oh, that was cool, let me show you that. And I was bored. I had nothing to do. I had nothing to lose. So I walked up to this group of performers. I interrupted, and moments later, I left them speechless. I'm going to show you what I showed them. Let's get a camera feed there. And you've got those cards. Are they mixed? All right, I'm going to try to do this as fairly as I can. No switches. I'm not going to look at them. Well, I saw one. I saw the last one as a red card. But other than that, I don't know. And so I walked up to these, and I said, hey, do you mind if I borrow your deck of cards? And they're, sure, why not? And I took the cards, and I started dealing. And I just started dealing in any order, and these performers just sort of watched, like, what is this guy doing? And then I asked, I said, do you know the magic trick Out of This World? Now, Out of This World is a fairly well-established card trick. It's been around for about 70 years. And the effect is normally you have a participant take a deck of cards and they deal them into two piles, just like I'm doing here. And the idea is that even though they're not a magician and they don't know what's going on, they're dealing the cards and somehow all the blacks end up in one pile and all the red cards end up in another pile. And so they're kind of confused because this is not how Out of This World goes. And they're watching me kind of wondering what's going on next, and they're like, yeah, of course we know about Paul Curry's Out of This World from the 1940s. There's nothing new there. And I said, well, this is my version of it, where basically, after you're done dealing, and I just turned them over. I said, all the black cards are together, and all the red cards are together. Thank you. Now, they watched this, and they were speechless. It wasn't until a little while later that one of the group said, ha, what is this sorcery? And he was only half joking, because he had no idea. And nobody there had no idea. In fact, when he asked that question, what is this sorcery? I just smiled and walked off. And as I was walking away, I could hear their conversation turn from whatever it was they were trying to show each other to, how did that just happen? And I am told that that conversation continued not only through the night, but through the rest of the conference. And we'll switch back. Are we back? Oh, yes, that's right. That's where I'm supposed to be. Now, what is this sorcery? And depending on your background, how much you know about magic or not, that might just seem like another card trick. But to that group, it was a miracle. And it didn't matter how much they knew. I had one fact that they didn't, and that was the linchpin. And that was what left them mystified. And so, like I said, Paul Curry's Out of This World, it's not a new trick. 1942, it was first published. And normally, you have the deck of cards. As the magician, you'll do some prearrangement, you'll do some setup, you'll do some sneaky thing. And then you give the deck to the spectator, the participant, to deal, and they don't realize that you've done some sneaky thing. But when I did my version, there was no sneaky thing. I took their cards that they'd been using and shuffling and dropping and picking up and everything else that they had been doing, and I just took them and I immediately started dealing. They knew there was no prearranged order to the card because they were shuffled. They were in use. They knew the cards weren't special or marked in any way because they were their cards. But it fooled them because of that linchpin fact. And most magic works this way. That, in fact, if you look at this from Magicpedia, the method, though simple, is well hidden. And if you saw somebody do out of this world, and you knew that method, very simple, that one detail of the method, it wouldn't fool you. Now, you can know the method or the secret behind that trick and be fooled by other tricks. But it's always that linchpin, the one idea, the one fact that separates you from the solution or not. And it doesn't matter how much you know about magic. If you're missing one single fact, you can't get to the solution. Now, I get asked by people from time to time, they say, does magic ever fool you? You've been a magician, a professional magician, for 25 years. Does magic ever fool you? And the answer is yes, but very rarely. You see, in my 25 years, I have studied this field extensively. I've read hundreds of books from mainstream publications to very obscure, out-of-print, unusual pieces. I've ventured outside my direct field of magic and learned things about gambling and mediums and psychics and psychology and engineering and mathematics. And I try to connect all of these ideas into what I do as a performer. But as a result, I've accumulated thousands and thousands and thousands of these magical principles. Now, most magic tricks rely on just one or two. And I have, in my mind, a mental model of many thousands of these. So very rarely, I see a magic trick that relies on either one of those principles that I'm not familiar with or uses one of those principles in a way that I don't expect, in a way that surprises me. And all of this is what we call linchpin knowledge. Facts, ideas, or patterns that single-handedly bring the whole solution together. The one dot that connects all of the dots. And I told you that young man, when he exclaimed in that moment after I separated the colors of his cards, he said, "What is this sorcery?" And I get asked this question a lot when I perform. It's a popular, common, comedic answer or a response to what they've just seen that doesn't make sense. What is this sorcery? But I think it might make more sense if we rephrase it somewhat. If we take this statement and we just add a comma. What is this? Sorcery? And the answer is yes. You see, Jeff McBride, the #1 headliner of the 2004 Daytona Beach Festival of Magic, he has since become a friend, a mentor, a teacher to me. And I've had a friendship and a mentorship with Jeff McBride for those 2 decades since the Daytona Beach Festival of Magic. And Jeff describes sorcery very simply. You know, he studies the ancient arts. He studies alchemy. He studies all of these ancient wizards and ancient sorcerers and ancient wonder workers. And there's a common theme. Sorcery literally means access to sources. A sorcerer is one who has access to sources. So whether you're a modern-day wonder worker or a sorcerer or a wizard of a bygone era, you could only do what you did because you had access to sources. Now, those sources universally are knowledge and technology. But When you show somebody something so baffling, so out of alignment with their model of the world, they usually assume that the only possible sources that you could have access to are the supernatural. Now, this is why Arthur C. Clarke famously said, any sufficiently advanced technology is indistinguishable from magic. This is actually one of Arthur C. Clarke's 3 laws. He also said, when a distinguished but elderly scientist states that something is possible, he is almost certainly right. And when he states that something is impossible, he is very probably wrong. More is possible than we imagine. And if we believe something is possible, we're probably right. And if we think we know it all and we know this can't be done, we're probably wrong. He also stated that the only way of discovering the limits of the possible is venture a little way past them into the impossible. And that's why I like spending so much of my time there. And like I said, these are Clarke's 3 laws. He was asked once why there weren't more. And he said, 3 laws were good enough for Newton, so I guess those are good enough for me. But if you think about it, the software that we create is truly magical. If I go back to the late 1980s, early 1990s, and I'm going to date myself a little bit, you'll see how old I really am, I got a copy of Byte magazine. Anybody? Okay, a couple. And in the back of Byte magazine, there was always a basic program. And I would stay up late at night, laboriously typing every instruction of that program into my Apple II. And then I would run it and find out I made a typo somewhere again and again. But eventually it would work. And that particular program that I wrote was a program called Eliza. It was if you're not familiar, Eliza was one of the earliest chatbot-style programs that didn't chat very well, but it was still surprising and impressive at the time. And in fact, just like today, when people are looking at generative pre-trained language models and seeing intelligence, 60, 70 years ago, or 60 years, I guess, 50, 60 years ago, when people first saw Eliza, they thought the same thing. Eliza was supposed to be a virtual psychiatrist. And so you would open this up and you'd be given the prompt, what seems to be the problem today? And you say, well, I've been very depressed lately. Oh, sorry to hear that. Why do you think you've been very depressed lately? Well, I had a rough childhood. Tell me about, how do you feel about having had a rough childhood? Well, not great. Tell me more. And it mimicked this style of psychology, which is basically taking everything you say and phrasing it back at you with a question. And that's all it did. It did a very simple syntactic transformation to turn every statement into a question. But a couple of years ago, you show me something like ChatGPT, and I'd say, that's absurd. But here it is. One of my favorite conference talks that I've ever had the privilege to watch is Jessica Kerr's The Origins of Opera and the Future of Software Development. And I think if you watch this, you'll see there's a very strong influence. I was very inspired by this talk. But I loved the way that she approached this debate that we have in our industry. Is software art or craft? Because some people say, I'm a software crafts person. Or no, software is art. Code is art. Code is like poetry. I am an artist. And Jessica said, these are both wrong. She says, software, let me try that again. Software is not craft. We're not house painters. Software is not art. Software is the next thing after art. It's something new that we've never been able to do before. And she came up with the best analogy I've ever seen. She said, in my pocket, I have this piece of metal and glass, and if I touch it in just the right way, a car will show up wherever I happen to be and drive me anywhere I want to go. That's not art, that's not craft, that's something else. And if I touch it differently, The meal of my choice will show up at my doorstep. That is something else. That is something new. And like the sorcerers and the magicians of wizards, we use our knowledge to conjure a new reality. And we rely on sources, be they the knowledge, the teachings from an event like this, be they the books, the courses, the videos, be they the literal sources, thank you, Richard Stallman. But this is how we work the magic that we do. And just like in magic, missing that one linchpin fact, that one tiny gap in my knowledge can be devastating. And that's why these linchpins are so worrying for us. And this is why we have to be so aware and deliberate in finding them and building this breadth. So I've got a definition here. It says a linchpin is a person or thing that serves as the essential element in a complicated or delicate system or structure. It is the one that holds everything together. And that's what a linchpin fact is. So the solution is simple. We just learn as much as we can. We just learn everything. Because our field is small enough and contained enough that one person can learn everything, right? Yeah. 2017, New Scientist published a really great issue, the April 1st issue of New Scientist in 2017. Really great issue. And it explored the ideas of what is knowledge, how do we learn, how much can we learn? And one of the articles in that issue was written by someone named Sam O'Neill, and he was exploring the idea of what is the maximum that one person can know. And Sam O'Neill coined this term he called a person byte. And a person byte is the limit of what we can reasonably learn and know in a lifetime. It's not our storage capacity of our brains, which we keep finding we can store more in there. Current estimates that I found is something like, I think it's 32 petabytes or something like that. Maybe I have that in my notes. I don't know. Yeah, but a person byte is a much lower bound on that because we don't have the same bandwidth as a 5G network. We can't yet in the matrix say, I need to know how to fly a helicopter right now, and they can just download all of that into my brain. We have to learn the slow, laborious way. And that's where the ceiling of a person byte comes in. And, oh yeah, current estimates suggest our brains can store 1 petabyte. I massively overestimated that. But of course, our field of software engineering and all the things that we need to know vastly exceed that. So there are always going to be gaps in our knowledge. And for the most part, that's not that big of a deal. Because how many times a day do we go onto Google or DuckDuckGo or Bing if you're me and you hate yourself? I do use Bing. I have for quite a while. It's because I don't like Google. You know, I mean, they're fine, but it's a deliberate choice. It means that it means that I'm sufficiently grumpy with Google right now that I would rather not find what I'm searching for than use their search engine. But this is what we do. How many times a day do we do this? We go onto Bing or DuckDuckGo or Google or, are there other ones? I don't know. ChatGPT, yes. And we say things like this. How do I do X in framework Y? How do I apply this construct from this language in Java to Python? And what we're talking about here when you're asking those questions, and I do this a lot. It's just like, oh, how do I do this in that language? How do I do that in this framework? How do I do this other thing? How do I create a hash map in this language? Oh, it's called a dictionary, okay. But these are what they call known unknowns. I know that I don't know how to do that. And moreover, because I know what it is that I don't know how to do, I know how to ask the World Wide Web or ChatGPT or anything else. But then there's the more insidious unknown unknowns. This is the famous quote from Donald Rumsfeld. There are known knowns. These are the things that we know we know. There are the known unknowns. That is to say, there are things that we know we don't know. But there are also unknown unknowns. The things that we don't even know that we don't know. And these are the insidious ones, and these are where the linchpin knowledge is hiding. And the landscape of software is changing. You know, we talk about ChatGPT a lot. This, if you're not familiar with this, is called the Cynefin framework. And it's a way of classifying different problems into various domains of complexity. It's evolved over the years. This bottom right quadrant used to be called simple or obvious. It's been renamed to clear. It's tightly constrained. And you basically just follow best practices. And then there's the complicated domain, where it's not quite as simple. There's a little more moving parts. There are some governing constraints. But you're generally in a good place as long as you follow good practice. But when we look at something like Copilot or ChatGPT and its ability to generate code, if you're like me, the first time you saw that, my reaction was, oh no. But over time, as I play with this more and more, ChatGPT is really good in the clear domain because it's trained on all of these examples that have come over and over again and simple variations of it. There's a joke that I learned from Ken. Can I tell that joke? ChatGPT walks in a bar, and the bartender says, "What do you have?" And ChatGPT says, "I'll have what everybody else is having." But the novel, the emergent, the complex, this is where we still need thinking, reasoning, rational, knowledgeable, creative software engineers. These are the problems that haven't been solved yet. And you can't train a model on a solution that hasn't been created yet. This is where we need to reside. Because whether we like it or not, the low-hanging fruit, the simple, routine, rote tasks, the kind of software that people make a good living today, which is really just gluing together packages in a framework, that is going to get disrupted. But the people who can operate efficiently and effectively and creatively in the complex domain, those are the people that are going to thrive. So it means that we cannot coast on the familiar patterns and practices anymore. We need to level up our value proposition. We need to move up the value chain in an organization. The most valuable programmers of the next decade are those who can discover the linchpins and translate these into a vision and a direction that teams and organizations can follow. So, how do we discover unknown unknowns? If we don't even know what we don't know, how do we find it? Blind luck? Well, it really comes down to shifting the way that we work. And this means less typing, more thinking. And we need to spend more time in the problem space. And it means that we have to spend less time in the solution space. Now, what do I mean by that? Well, these terms, these ideas, the problem space and the solution space, go back to Herb Powell and Simon Newell. Herb Simon and Alan Newell. You'd think I'd remember this by now. In 1972, they published this book, Human Problem Solving. These are two really interesting individuals in the history of computer science, by the way. They were among the first people to see computers as more than just labor-saving devices for human computers. Because back in their era, computers were people. A computer was a job. You could be a doctor, you could be a lawyer, you could be a clerk, you could be a computer. And computers, it was just, it was semi-skilled labor at best. You would just do the number crunching. You would do the math. And the first computers were really just seen as labor-saving devices like any other mechanization or automation of human labor. And they were the first to say, you know, there's potential in these things beyond just doing a lot of calculations. I wonder if these machines can reason. And they built some of the first software capable of reasoning and logical deduction and complex problem solving. But they wrote this book and they coined, and their work, in fact, that was summarized in this book, eventually won them a Turing Award. But they coined these concepts of the problem space and the solution space. Now, these concepts were repopularized by Dan Olson in the Lean Product Playbook. But really, if we look at this, the solution space and the problem space break down like this. The problem space is where all the technologies live. It's where the tools live, the patterns, the frameworks, the libraries, the languages. These are the things that look good on our resumes. The solution space has the answers. The problem space is not nearly as cool and doesn't look nearly as good on our resume. They're the business drivers, the problem context, the underlying need, the questions. And so the problem space is decidedly less interesting from an engineering perspective. In fact, I learned to program on an Apple II a few decades ago. Who's counting? And back in those days, I didn't have requirements. I didn't have customers. I just wanted to play with the computer. I wanted to play with the language. I wanted to see what I could make it do. That's how I fell in love with this field. And that's how I continued to learn and get a job and everything like that. But it's easy for the solution space to be a default. And but the problem space is where the questions reside. The problem space is where we can begin to ask the right questions. And most of what we learn, most of what's out there, and in reality, most of the sessions that we're going to sit in this week, most of the books that we're going to read in our career, most of the videos and courses, almost all of them are focused on building more depth in the solution space. But we might have the answers, but do we know the questions? And I can't help but think of the fabulous book, radio show, book, television series, movie, another movie, The Hitchhiker's Guide to the Galaxy, and maybe you're familiar with this. And if you'll recall, if you're familiar with, this is the original BBC television series, or the BBC radio series, or even the movie, which wasn't great, unfortunately, or the book. The book is fabulous. You'll recall that yes, they wanted the answer to life, the universe, and everything, and the answer was 42. And so they had to build another computer because although that computer, deep thought, was very powerful, it was not powerful enough to figure out the question. And the answer took 7.5 million years. The question took 10. The questions are harder than the answers. Supposedly, Albert Einstein said this: if I had an hour to solve a problem, my life depended on it, I would spend the first 55 minutes determining the proper question to ask. For once I know the proper question, I could solve the problem in less than 5 minutes. I remember years ago, I found myself in a job interview, and they asked me one of those lateral thinking questions that make me angry. It's like, I'm an engineer. Why are you asking me about light bulbs in sealed rooms? Have you heard this one? There are 3 light bulbs in a room. The door is shut. There are 3 light switches outside the door. You can turn them on and off as much as you want, but once you open the door, you have to conclusively state which switch corresponds to which light bulb. Now, I did not figure it out in the allotted time, and I was angry about this. I felt it was their fault for not asking me a good question. But it really taught me something, because I obsessed over this, because I do that sometimes. When I can't figure something out, I obsess over it for a very long time. And eventually, I figured out the question I needed to ask. The question that I needed to ask is, how can I get a third state on a light bulb? Because there's an on state and an off state. But if I'm gonna map 3 switches to 3 light bulbs, then I need to be able to measure a third state. So what's a third state a light bulb can have? Yeah, temperature. It can be burned out. It can be, a lot of these things. But temperature. So especially if it's an incandescent bulb. This is before LEDs were, cheap and plentiful. And so you turn one on, leave it on for 10, 15 minutes, and then turn it off, and then turn one of the other ones on. So now you have a hot bulb, which corresponds to the first one, an on, which corresponds to the second switch, and an off that corresponds to the third switch. And now you know. And it was the question that got me there. And it's amazing how many of these types of crazy lateral thinking questions you can answer just by figuring out the right question. And when you understand the problem, the business context, and you ask the right questions at the outset, it's gonna take you to interesting and unexpected places. When you jump directly into the solution space, it's interesting, but it's not generally gonna yield a lot of new ideas. And often when you jump right into the solution space, what can happen is you'll reinvent you'll end up just reinventing the wheel or recreating a lot of work that's already been done. Or, as Ken Cousin, who I'm going to plagiarize for the third time today, is fond of saying, more often than not, when you reinvent the wheel, you really just reinvent the flat tire. Filling in the linchpins requires new and unique perspectives. We gain all of these new and unique perspectives when we deviate from the course of deep specialization, when we start to cultivate range, when we explore ideas outside of our core domain. So this is a really great book I read last year called Range by David Epstein. And really it's sort of the answer to, a response to Malcolm Gladwell's 10,000-hour hypothesis. Maybe you're familiar with either that idea or the book Outliers by Malcolm Gladwell, where he said that the path to mastery is deep specialization with 10,000 hours of deliberate practice. And what David Epstein says in this book is, well, yes, but only in certain domains. He draws a distinction between what he calls kind domains and wicked domains. Kind domains are domains that have a really well-defined set of rules, really well-defined set of constraints, and really fast and consistent feedback. Something like the game of chess. Now, contrast that with the wicked domains. These don't have a clear set of constraints. They don't have a clear set of rules that you can follow. They don't have a fast feedback mechanisms. Sometimes you don't get feedback at all. Sometimes you get feedback very slowly. And this is why decades and decades ago, back when we thought chess was the pinnacle of human intellect, we were able to make a machine that could beat the best chess players in the world. But those machines can't drive a car. And we've been told now for 12 years running that any day now we'll have fully autonomous self-driving cars, but the complexity of that domain, that is definitely a wicked domain, and that's so much harder. And in fact, countries are starting to realize if we want autonomous driving, we need to build purpose-built specialty infrastructure that makes it a much more kind domain. But he talks about, in this book, David Epstein talks about the people who have range, the people who have a breadth of perspectives, the people who can connect different and diverse ideas. Those are the people who are going to succeed in the complex domains. And in fact, he's got a quote here. He says, "Modern work demands knowledge transfer, the ability to apply knowledge to new situations and different domains. Our most fundamental thought processes have changed to accommodate increasing complexity and the need to derive new patterns rather than only relying on familiar ones." So I want to go back to that card trick for a minute. How did I fool all those magicians? One thing. Why did I know it, but they didn't? Because I chose a broader course of study. As I was learning magic, I took anything I could get a hold of, anything I could get my hands on, including an obscure book from 1902 about card cheating. This is, in fact, the seminal work on how to cheat at cards. It was written by it was written by an author who wrote under a pseudonym. The pseudonym was S.W. Erdonez. And for years, people thought, who is S.W. Erdonez? And then they found out that S.W. Erdonez is actually E.S. Andrews backwards. And that got them nowhere. They have a pretty solid theory on who it was. But even though magic and card cheating are fairly adjacent domains, It's less interesting to magicians because they're more interested in tricks and things like that. And I was just curious how people took the same sleights and applied them differently. Applied them under pressure. Because Di Vernon, the professor, was very fond of saying that the difference between magicians and gamblers is the magicians always do their moves when you're not looking. And gamblers don't have that luxury. So it was like an interesting diversion of study. And it was by diving into this field that I learned about a long-forgotten utility device that the card cheats of yesteryear would use to cheat at cards, something called a shiner. Little metal disc attached to the forefingers enables a card worker to sight the index of a card on its bright surface. It is at times an artful accomplice. This trick will fool 99 out of 100 magicians because 99 out of 100 magicians have never heard of a shiner. Or it's not ingrained enough in their mental model that they would even see that as a possibility. Now, all I did back in those days was fool some magicians. They were highly skilled, and they were very knowledgeable, but the absence of that fact allowed me to fool them, allowed them to be incapable of solving the puzzle. And it was specialization that fooled them. Now, all I did was fool some magicians by taking a weird tangential learning path. But sometimes I wonder where we would be if more consequential people in history hadn't taken tangential learning paths. This is Claude Shannon. He used to work at Bell Labs. He was in the 1930s, he was studying engineering and mathematics at the University of Michigan in America. And for some reason, I don't know if it was a requirement or a whim or a flight of fancy, he said, you know what? I think I'm going to take a philosophy class. Not what you would expect from an engineer. Navel-gazing discussions about how many angels can dance on the head of a pin. But he took that class. And it was in that class that he learned of the work that happened 90 years previous, in the middle of the 19th century, the work of somebody named George Boole. Nobody had heard of George Boole, but you've heard of Boole. See, George Boole had this idea, because there's a lot of discussion going all the way back to Aristotle and Heraclitus of logos, logic, one of the three pillars of rhetoric. And George Boole had this idea of, what if we just simplified our discussions of logic and rhetoric and what is and is not down into its barest essence? What if we represented something that is true with a 1, and we represented something that is false with a 0? That doesn't matter what those statements are, but they're either true or false. Well, then we can start chaining that reasoning and chaining multiple statements. And it was an interesting idea that scholars of the day said, huh, and then we forgot about it. Claude Shannon discovered it. And then when he was designing circuits, he said, wait a minute, what if we did this same thing with electrical signals? And modern digital computing was born. Now, he could have spent his life recreating, either doing what everybody had been doing in that moment, which was just creating really complicated spaghetti ad hoc series of circuits, or he could have spent his life recreating George Boole's life work. But instead, he made a major world-changing discovery while he was still in grad school, because he connected these two ideas from diverse fields. And he said, you know, when he was lauded for this, he says, it just happened that no one else was familiar with both fields at the same time. And this was not the first nor the last time some unexpected linchpin knowledge would change the course of history. Another notable example was the story that Steve Jobs told in 2005 when he gave the commencement speech at Stanford. Now, whatever you think of the guy, and I have complicated feelings, there is wisdom in this story. You know, he gets up there, and it's got to feel weird to give a commencement speech to a graduating class as somebody who's never graduated, never matriculated, never finished university. He dropped out. But he talks about that. And he says, he talks about how dropping out allowed him to follow his curiosity and as a consequence cultivate range, a breadth of perspectives, a breadth of mental models, a breadth of ideas that had no value seemingly in the moment, but in the future, those things that he learned became the linchpin to success. And so the key is to let your curiosity and intuition guide you. Guide you into areas that aren't going to have any immediate utility to what you're learning. And because you never know when some random, seemingly irrelevant idea or pattern or anything or this perspective is going to be the crucial linchpin to a future problem. And my challenge to you today and during this conference is pick one session that has nothing to do with the problems that you're facing today, the work that you're doing today, the tools you're using today. Just pick one session and drop into it. Find the one that makes you say, huh, let your curiosity and intuition guide you. You know, for me, one of the things because I always do this at conferences, I'll find at least one session. And generally, I go into the one that's like, I have no idea what they're even talking about. Let me find out. And, you know, because again, it's important that you let your intuition guide you because it's easy to see what's going to help you build depth right now, but it is impossible to see what's going to be the linchpin fact in your future. And there's so much value in developing your own cognitive diversity. You should absolutely open your mind to new ideas and new approaches. You know, these things, these diverse experiences. Again, they don't always have immediate value, but you never know when they're going to arm you with a future linchpin. Now, great. We still have this problem of the person bite, though. Because no matter what you do, no matter how many drop-in sessions you sit in, you will never overcome the person bite. And that's why there's one more piece of the puzzle. It's not just about you. There's a great book years ago called The Wisdom of Crowds. And what transpired from this is teams, particularly diverse teams, are always more effective than individuals. You know, one of the examples that gets commonly cited is something like this: a jar of jelly beans. How many jelly beans are in there? Now, if I asked you, you'd have a guess. It might be a good guess, it might be a bad guess. 500, sure. Who has a different guess? 1,000. These are very different answers. But what we found out is that the average of all of the guesses is almost always spot on or off by 1 or 2 jelly beans. You know, there's a great professor, I'm blanking on his name, but he gives a course on diversity and why thinking differently is your greatest asset. And in one of his classes, he asked the students to guess how tall in stories the tallest building in Rio de Janeiro was. And somebody said, well, you know, it's a major city, it's one of the biggest cities in South America, so I'm going to guess 80. And somebody else said, well, you know what, it is a city, but it's a beach town. And, you know, the view matters and things like that, so I'm going to guess 30. And somebody else guessed that it's not really a financial hub, and the big tall buildings are usually where the financial hubs are, so I'm going to guess 50. And what happened was every person not only had a different guess, but their guess was based on a different mental model. And these ensemble models tend to work better. So if you really want to 10x your creativity and your problem solving, then it's important not just to scale up your knowledge and cognitive diversity, but scale it out. The sage Bill Nye reminds us that literally every person you will ever meet knows something that you don't. And there is truth and wisdom, but the key thing is they have to know something you don't about the problem at hand. And they have to know something you don't that is relevant. And that's why we want people, we don't want just any team, we want a team of people who think differently, a cognitively diverse team, and often this comes from, there's a lot of diversity initiatives and organizations, and these initiatives tend to focus on identity diversity. But different identities give us different perspectives, different mental models. So but you're striving for cognitive diversity, and there's lots of ways to get there. A common condiment in every household in the West is ketchup. And this is an example that I got asked once. I was in a session, and the speaker said, "Where do you keep your ketchup?" And I said, "In the fridge," and most of us say, "In the fridge." "Ken, where's your ketchup?" "In the cupboard." All right. And it turns out it doesn't really matter, because there's enough sugar and vinegar and whatnot in ketchup that it's largely shelf-stable for a long time. But a fridge person, if I open my fridge and I don't have any ketchup, I've run out, well, I'm going to look in the fridge for an alternative. Maybe I'll get mayonnaise, maybe I'll get ranch dressing, maybe I'll get whatever. But if you go to the cupboard and there's no ketchup, you're going to have an entirely different set of alternatives. Maybe you're going to go for some vinegar. Maybe you're going to go for, I don't know. Maybe you're going to go for just some different seasoning. And you'll just make some seasoned fries. Maybe you'll get some masala or peri-peri. I don't know. That's diversity. And so, when we look at history, we have this myth of the lone innovator. And a lot of people have deified Steve Jobs as this giant innovator. But Jobs would be nothing without Woz in the 1970s and 80s. And the second coming of Steve Jobs would have been nothing without Joni Ive. And it is teams, it is diverse perspectives. And when we look back through history, yeah, there were lone innovators who came up with these great breakthroughs, but the low-hanging fruit in science and technology are gone. And if you look at Nobel Prizes or academic papers, the team of people who make these breakthroughs is getting larger and larger and larger. And in fact, the size of the team is generally proportional to the importance of the paper. If we look at Nobel Prizes throughout history, the first Nobel Prizes were awarded to a total of 19 people. So that's just over one person per Nobel Prize discovery. When we look at the last 15 Nobel Prizes, they were awarded to 42 people. And that's notable because at most, only 3 people can be awarded the Nobel Prize for their cooperation on a discovery. And in all of those, there were many people who felt that their contributions had been overlooked. So the real number of people that made it possible for these Nobel Prize-winning discoveries is probably much higher, probably in the hundreds at this point. And I want to come back to this as we close. Magic is about secrets. And I just violated one of the most sacred rules of magic to make a point. But what is magic really about? It's not about ego. It's about giving your audience an astonishing experience. When we think of the emotions that we experience in life, how often are you happy? How often are you sad? How often are you embarrassed? How often are you angry? Frustrated? How often do you experience joy? These are fairly common. When was the last time you experienced the emotion of astonishment? It's incredibly rare. It's one of the rarest emotions. And so for me, magic is about giving the gift of astonishment. But too many performers get in the magic with the attitude of, let me show you something that you don't know how to do. Don't know how I did this, did it? Look how talented I am. I have a friend of mine has been obsessing about this magician on YouTube or Instagram or one of the social sites. And his entire attitude is, you'll just have to accept that I'm the best there is, and I know all these things that you don't. And it was like funny the first time. But when it's like every single video, it grows tiresome. And it's not about ego. It can't be about ego. And the same thing in your career as a software engineer. There was a time when you could make a good career knowing all the answers. And that era has passed. Learn to work with people. Learn to empathize with people. Learn and cultivate your range. Help your teams cultivate their breadth and range. And create that culture. Now, there are still organizations with an antiquated culture where they're looking at, the individual contributor who, changed everything. And it's up to us to change that culture. And we do it by making sure that the team succeeds or the team fails. So I don't gatekeep my magician foolers anymore. I actually teach them the magicians. And I show them how they can expand their breadth of perspective. And we want to not gatekeep our knowledge. We want our teams to be more effective. So wrapping up, because we've got about a minute left, our industry is shifting under our feet. The problems that we're going to have to solve in the coming years are going to require diversity of mental model, diversity of perspective, diversity of experience, different ideas, connecting ideas across domains. And there's I had a really great conversation with Venkat Subramaniam a few years ago, and he talked about this same thing, following curiosity. When you learn functional programming, even though it had no immediate value to you, and it turned out to be just the thing to help you solve a future problem. Because we don't learn in these big, I'm paraphrasing Venkat now, we don't learn in these big discrete dumps. We learn in tiny deltas. And each delta, each thing we learn creates a little more, a platform for the next thing to learn and the next thing to learn. And so by doing this, we're creating fertile soil for new ideas to take root. And cognitive diversity in yourself and your team is going to be your ace in the hole. And remember that just like in magic, it's easy once you know the secret. Thank you.